For a few fleeting minutes, the world holds its breath. The sun begins to vanish. A deep awe descends upon the landscape. This is the magic of a total solar eclipse, a moment that connects us across millennia. It is a profound spectacle that touches the very core of human emotion. The air grows still. A strange silvery light bathes the world. We are reminded that we are inhabitants of a dynamic cosmos. For a moment, we are simply inhabitants of Earth, witnessing a celestial performance. It is an invitation to look up and see the sky as a place of immense power and beauty. The awe it inspires urges us to look closer and learn more. The human reaction to a total solar eclipse transcends time and culture. It evokes a primal sense of wonder, a reverent silence as the final sliver of sunlight disappears. The sudden plunge into midday darkness triggers something ancient within us. People cheer. They weep. They embrace one another. The overwhelming beauty of the sun's corona can be a profoundly moving sight. It speaks directly to our capacity for wonder, reminding us of the universe's mysteries. The beauty of an eclipse is its ability to touch everyone. It serves as a powerful reminder of the vast celestial neighborhood in which we reside. Ultimately, the universal reaction is one of connection. There is also a powerful sense of connection to each other. This feeling of unity is perhaps one of the most enduring and valuable gifts that an eclipse can bestow upon us. An eclipse is a celestial ballet choreographed by gravity. It's a cosmic coincidence that makes life on Earth so unique. The sun is 400 times wider than our moon, yet it is also approximately 400 times farther away. From Earth, the sun and the moon appear to be almost exactly the same size in the sky. This allows the moon to completely obscure the sun, creating a total solar eclipse. This requires the sun, the moon, and the Earth to fall into a perfectly straight line. If the moon is farther from Earth, it will result in an annular or ring of fire eclipse. In the final moments before totality, the world transforms. The final beat of light creates the diamond ring effect, and then the sun's magnificent corona bursts into view. This is the moment of totality, a sight that has captivated humanity for eons. A total solar eclipse defies our ordinary experience. Our lives are governed by the predictable cycle of day and night. An eclipse shatters this rule. For a few minutes, in the middle of the day, night falls. This journey beyond the ordinary is a multi-sensory experience felt throughout the environment. The air cools. Animals and birds, confused by the sudden onset of night, may become silent. The quality of the light itself is perhaps the most alien aspect of the experience. In the minutes leading up to totality, the sunlight takes on a strange, silvery, and almost metallic quality. Standing in the moon's shadow, or umbra, is to be momentarily disconnected from the familiar world. It is an experience that pushes the boundaries of perception. Behind an eclipse lies a rich story, spanning science, myth, and cultural interpretation. Eclipses were once viewed with fear, as omens or cosmic battles. Ancient cultures developed myths to explain the sun's disappearance. In China, a dragon devoured the sun. These myths reflect a human need to understand powerful events. Babylonians meticulously recorded eclipses, seeking patterns. Today, eclipses offer invaluable opportunities for scientific discovery. They allow us a glimpse of the sun's corona, helping us understand solar flares. The eclipse story mirrors humanity's intellectual evolution, from fear to understanding. Ultimately, an eclipse is an invitation. It is an invitation to look up, to wonder, and to seek a deeper understanding of the universe around us. This temporary obscuration of our star does more than just create a beautiful spectacle. It ignites curiosity. For many, witnessing an eclipse is the spark that ignites a lifelong passion for science and astronomy. The event presents a grand cosmic puzzle in the sky and dares us to try and solve it. It prompts fundamental questions. Why does this happen? How can we predict it with such accuracy? What does it tell us about the sun, the moon, and our own planet? This quest for knowledge is not a solitary pursuit. Eclipses are global events, and they foster a sense of collective discovery. In the modern era, they bring together professional scientists, amateur astronomers, and the general public in a massive, collaborative effort. Citizen science projects flourish during eclipses, with thousands of people contributing valuable data and observations from along the path of totality. This shared endeavor breaks down the barriers between the scientific community and the public, creating an environment where everyone can participate in the process of discovery and feel a part of something larger than themselves. The precise cosmic geometry that allows such a phenomenon to occur with predictable regularity is a testament to the underlying order of the universe. It reveals a cosmos governed not by chaos or the whims of deities, but by elegant and understandable physical laws. The ability of science to forecast the time and location of an eclipse down to the second, decades, or even centuries in advance is one of its most powerful triumphs. It demonstrates a profound comprehension of the celestial mechanics that govern our solar system. Observing an eclipse is to witness this cosmic clockwork in action, a powerful and humbling reminder of the intricate harmony of the universe. Therefore, the story that begins with a fleeting shadow in the sky concludes with a lasting impact on the human mind. It is a story of discovery, a journey that has taken us from fear to fascination. It is a story of understanding, revealing the elegant dance of celestial bodies. And it is, ultimately, a story that fosters a deeper connection to the cosmos. An eclipse invites us to contemplate not just the sky, but our own place within it. It encourages us to continue asking questions, to keep exploring, and to never lose our sense of wonder at the grand and beautiful universe we are privileged to inhabit. An eclipse is a moment of perfect alignment in space. It occurs when one celestial body moves into the shadow of another. Here on Earth, we witness solar and lunar eclipses. They demonstrate the clockwork precision governing the orbits of Earth and the Moon around the Sun. For a solar eclipse, the Moon passes in front of the Sun. For a lunar eclipse, the Earth casts its shadow upon the Moon. These events are natural and predictable, a testament to the gravitational laws that choreograph this cosmic dance. Eclipses reveal the three-dimensional space through which our planet and its companion are constantly moving. A solar eclipse is a dramatic event. It occurs when the Moon passes between the Sun and Earth. The Moon casts a shadow, partially or completely blocking out the Sun. The Sun's diameter is 400 times larger than the Moon's, but it is also 400 times farther away. From Earth, they appear almost the same size, allowing the Moon to cover the Sun. The Moon's shadow has two parts. The umbra causes a total solar eclipse. The penumbra causes a partial solar eclipse. The umbral shadow traces a narrow path, making totality rare. The shadow sweeps across Earth at incredible speeds. Totality is brief, lasting seconds to minutes. This brief window transforms the world. The sky darkens, revealing stars and planets. The temperature drops, and a pearly white halo appears. This is the Sun's corona. Seeing the corona reveals the majesty of our star. A total solar eclipse is one member of a diverse family of solar eclipses. The specific type depends on the alignment of the Sun, Moon, and Earth, and the Moon's distance from our planet. The Moon's orbit is an ellipse. Sometimes the Moon is closer, appearing larger, and sometimes farther, appearing smaller. This size variation creates total eclipses, annular eclipses where a ring of sunlight is visible, and partial eclipses. A rare hybrid eclipse shifts between annular and total along its path due to Earth's curvature. Unlike a solar eclipse, a lunar eclipse offers a serene celestial spectacle. It happens when Earth passes between the Sun and Moon, its shadow obscuring the Moon. This occurs during a full moon. Earth casts its shadow into space, which the Moon then drifts through. Earth takes center stage. Earth's shadow is much larger than the Moon's. Anyone on Earth's night side can see it, weather permitting. Earth's shadow has two parts, the dark umbra and fainter penumbra. The real show begins when the Moon enters the umbra. A dark, curved bite is taken out of the Moon's edge. This curved shadow proves Earth is round. A lunar eclipse invites a relaxed viewing experience. Just as there are different types of solar eclipses, lunar eclipses also come in several forms, each defined by how deeply the moon travels into Earth's shadow. The most visually stunning of these is the total lunar eclipse. This occurs when the entire moon passes through Earth's dark umbral shadow. But instead of disappearing completely, the moon often takes on a beautiful and, honestly, kind of eerie reddish glow. This phenomenon has earned total lunar eclipses the popular nickname blood moon. This striking color is not a sign of something sinister, but rather a beautiful trick of the light caused by our own planet's atmosphere. The reddish hue of a total lunar eclipse is the result of sunlight being filtered through Earth's atmosphere. As sunlight passes through the ring of air surrounding our planet, the collective sunrises and sunsets of the world, the blue light is scattered away, while the red and orange light is bent or refracted into Earth's shadow. This faint, reddish light then travels through space to illuminate the eclipsed moon. The exact color and brightness of the blood moon can vary significantly from one eclipse to another, depending on the amount of dust, clouds, and volcanic ash present in Earth's atmosphere at the time, making each total lunar eclipse a unique event. When the moon does not pass completely into the umbra, we witness a partial lunar eclipse. During this event, only a part of the moon enters the darkest portion of Earth's shadow, while the rest remains in the fainter penumbra. To an observer, it looks as though a dark, curved bite has been taken out of the side of the full moon. These events are more common than total lunar eclipses and provide a clear and dramatic view of Earth's curved shadow moving across the lunar surface. It is a striking visual demonstration of the orbital mechanics that govern our corner of the solar system. The most subtle type of lunar eclipse is the penumbral eclipse. This happens when the moon passes only through Earth's faint, outer penumbral shadow and misses the umbra entirely. For a casual observer, a penumbral eclipse can be very difficult to notice. It causes only a slight, diffuse shading on the moon's face, making it appear a bit dimmer than a typical full moon. While it lacks the dramatic color of a total eclipse or the distinct shadow of a partial one, it is still a genuine astronomical event, a testament to the precision of orbital alignments and the vast, faint reach of our planet's shadow. Solar and lunar eclipses result from a cosmic dance choreographed by gravity. They're a natural outcome of the Sun-Earth-Moon system's orbital mechanics. Eclipses are relatively rare because the moon's orbit is tilted. It's inclined just over 5 degrees relative to the ecliptic plane. Eclipses occur during eclipse seasons when the moon passes through the ecliptic plane at a node. This intersection means eclipses happen in cycles. The Saros cycle, about 18 years, predicts similar eclipses. Today, we predict eclipses centuries into the future with accuracy. This transforms eclipses into opportunities for science and shared wonder. They demonstrate a universe governed by comprehensible laws. Eclipses are not accidents of the cosmos. They are predictable and beautiful consequences of precise orbital mechanics. They are a grand symphony played out on a celestial scale, with the sun, Earth, and moon as the principal performers. The entire performance is governed by the force of gravity, which dictates the elegant looping paths these bodies trace through space. For an eclipse to occur, a moment of near-perfect alignment is required, a condition known in astronomy as a syzygy. During this brief alignment, one body casts a shadow upon another, temporarily altering the light we see from our terrestrial vantage point. It is this interplay of light, shadow, and motion that creates the spectacle we witness. The mechanics begin with the fundamental orbits themselves. The Earth traces a vast, nearly circular path around the Sun, a journey that takes 1 year to complete and defines the plane of our solar system, known as the ecliptic. At the same time, our Moon is engaged in its own smaller orbit, revolving around the Earth approximately once every month. It is this constant, nested motion, the Moon around the Earth and the Earth-Moon system around the Sun, that sets the stage for every eclipse. We are living on a moving platform within a system of other moving objects, and eclipses are the moments when these separate paths intersect in a visually spectacular way. The concept of a shadow is central to this entire mechanical process. Every opaque object in the solar system casts a shadow into space. These shadows are immense, cone-shaped regions of darkness that stretch for hundreds of thousands or even millions of miles behind the object. For most of their existence, these shadows drift harmlessly through the void of space. An eclipse occurs only when another celestial body happens to pass through one of these vast cones of darkness. Therefore, to truly understand the mechanics of an eclipse, we must visualize our solar system not just as a collection of bright objects, but also as a system of immense, invisible shadows constantly sweeping through space. A solar eclipse is the result of us, on Earth, passing through the moon's tiny shadow. A lunar eclipse is the result of the moon passing through Earth's much larger shadow. This perspective transforms the event from a simple covering of one object by another into a dynamic journey through a specific, defined region of space, a fleeting passage through a river of celestial darkness. The Earth and Moon cast complex shadows with distinct regions because the Sun is not a point source of light. The darkest, central part is the umbra. Within it, you'd experience a total solar eclipse. Surrounding the umbra is the fainter penumbra. Observers here see a partial eclipse. Beyond the umbra is the antumbra. Here, the occulting body appears too small to fully cover the Sun, creating a bright ring. Understanding these regions, umbra, penumbra, and antumbra, explains the different types of eclipses. The specific eclipse we witness depends on which shadow region we pass through. If the orbits of the Earth and Moon were perfectly aligned, eclipses would be a routine monthly occurrence. A solar eclipse would happen at every new moon, and a lunar eclipse would grace our skies at every full moon. They would be as common and predictable as the tides. However, as we know, eclipses are special, relatively rare events. The reason for this scarcity lies in a small but critically important detail of our solar system's architecture. The moon's orbit is tilted. It is not in the same plane as Earth's orbit around the Sun. This subtle misalignment is the primary reason we do not experience a constant cycle of eclipses. The Earth's path around the Sun defines a flat plane, much like a giant celestial dinner plate, which astronomers call the ecliptic plane. The moon's orbit around the Earth is its own plate, but it is tilted at an angle of approximately 5.14 degrees relative to the ecliptic. This may not sound like a large angle, but over the vast distances of space, it is more than enough to ensure a miss. Most of the time, during a new moon, the moon's tilted orbit causes it to pass either above or below the Sun in our sky. Its shadow is cast harmlessly into space, completely missing the Earth. Similarly, during most full moons, the moon is on the opposite side of the Earth from the Sun, but its tilt places it either above or below Earth's shadow. Our planet's massive shadow cone is cast out into space, but the moon sails past it, remaining fully illuminated by the Sun's light. It is only when the alignment is perfect, when the moon is at the right phase and also happens to be crossing the Earth's orbital plane, that an eclipse becomes possible. This requirement for a three-dimensional alignment, not just a two-dimensional one, is what makes eclipses precious and infrequent celestial appointments. This 5-degree tilt is a fundamental characteristic of the Earth-Moon system, likely a relic of the moon's violent formation billions of years ago. It adds a layer of complexity and elegance to the celestial mechanics that govern our skies. It creates specific eclipse seasons, short windows of opportunity during the year when the alignment is just right for shadows to intersect with worlds. This tilt transforms what would be a mundane monthly event into a rare and celebrated spectacle, a cosmic alignment that demands a perfect intersection of time, space, and geometry, making each one a moment to be cherished. The moon's orbit intersects the Earth's ecliptic plane at 2 points, the lunar nodes. These nodes drift or precess backwards along the ecliptic. The position of these nodes is key to predicting eclipses, which can only happen when the moon is at or near a node. Eclipse seasons occur when the Sun aligns with a lunar node, lasting about 34 days, roughly every 6 months. Eclipses often come in pairs, solar followed by lunar, or vice versa. The lunar nodes are celestial gateways for eclipses. Humanity's desire to understand eclipses is as old as civilization itself. Ancient cultures realized eclipses weren't random, discovering they repeat in a predictable pattern. This pattern is the Saros cycle, lasting about 18 years. After one Saros period, the Sun, Earth, and Moon return to nearly the same geometric arrangement. The Earth has rotated an additional 120 degrees on its axis. The discovery of the Saros cycle transformed eclipses into phenomena that followed a discernible cosmic rhythm. While the Saros cycle was a brilliant tool for ancient astronomers, letting them forecast eclipses far into the future, modern eclipse prediction has reached a level of precision that would have seemed, well, almost magical to them. Today, our understanding of orbital mechanics is built on Newton's laws of universal gravitation and refined even further by Einstein's theory of general relativity. We use powerful computers to run complex calculations that model the movements of the Sun, Earth, and Moon with extraordinary accuracy. These models actually account for dozens of subtle gravitational influences that can affect the exact timing and path of an eclipse. Modern calculations include incredibly fine details. They consider the gravitational pull of all the other planets in the solar system, which can slightly nudge the Earth and Moon out of their otherwise perfect orbits. They factor in the slight flattening of the Earth at its poles and its equatorial bulge, which subtly alter its gravitational field. Scientists even take into account the precise, rugged topography of the Moon's surface. By knowing the exact heights of lunar mountains and the depths of its valleys, they can predict the formation of Baily's beads and the diamond ring effect down to the split second at any given location. This amazing level of precision allows for the creation of highly detailed eclipse maps, available to both scientists and the public decades in advance. These maps can show the exact path of the umbral shadow as it sweeps across the Earth, indicating the start time, maximum eclipse, and end time for any city or landmark along the path. This kind of detail is absolutely crucial for planning scientific expeditions, organizing public viewing events, and making sure eclipse chasers can position themselves in the perfect spot to witness totality. It turns what was once a mysterious celestial event into a globally accessible, well-planned occasion. The ability to predict these events with such certainty is truly one of the great triumphs of the scientific method. It's a testament to centuries of accumulated knowledge, from the first Babylonian clay tablets all the way to the supercomputers of today. It shows that the universe, while vast and mysterious, is not random. It operates on a set of consistent, knowable physical laws. When we watch an eclipse unfold exactly when and how science predicted, we're witnessing a powerful confirmation of our ability to understand the cosmos. The mechanics of eclipses, once a source of fear and myth, are now a beautiful showcase of cosmic order and human ingenuity. Long before scientific understanding, a total solar eclipse was terrifying. Imagine a world lit by the sun, fire, and stars. Suddenly, the source of light vanishes, the sky darkens, the air turns cold, and a ghostly halo appears. Our ancestors saw this as cosmic chaos or divine displeasure. Early cultures created myths to explain this phenomenon, humanity's first attempt to order a chaotic universe. These weren't fairy tales, but fundamental pieces of their cosmology. The eclipse forced people to confront the immense power governing their world. These whispers from the ancient sky tell us about our history. The fear and wonder inspired by eclipses were powerful catalysts. The eclipse illuminated the path toward astronomy and the scientific quest for knowledge. In ancient China, the sun represented the emperor. An eclipse was a terrible omen, interpreted as a celestial dragon attacking the sun. People would bang pots and drums to frighten the dragon away. Court astronomers had to predict eclipses. Failure was a grave offense. This drove the Chinese to keep meticulous records of eclipses, providing a priceless historical resource. In Mesopotamia, the Babylonians believed celestial events mirrored earthly fortunes. Eclipses threatened the king, triggering the substitute king right. Driven by omens, they meticulously recorded celestial phenomena on clay tablets. This created an unparalleled database, leading to the discovery of the Saros cycle. This cycle allowed them to predict eclipses, transforming superstition into a predictive science. Deep within the jungles of Central America, the ancient Maya civilization developed one of the most sophisticated and complex astronomical systems in the ancient world. For the Maya, the cosmos was a place of divine order, and time itself was sacred, cyclical, and deeply intertwined with their religious beliefs. They were obsessed with tracking the movements of celestial bodies, particularly the sun, the moon, and the planet Venus, which they associated with their gods. Eclipses held a place of profound significance within this worldview, seen as moments of great power and potential danger, when the cosmic balance could be disrupted by powerful deities. The Maya, like other ancient cultures, associated eclipses with dark omens. They believed that during a solar eclipse, terrifying star demons, or tsitsimime, would descend to Earth to devour humanity. Glyphs found in their ancient texts, known as codices, depict a celestial serpent or monster swallowing the sun glyph. However, unlike many other cultures who responded with spontaneous noisemaking, the Maya approached eclipses with a deep and scholarly understanding. They were not just reacting to eclipses, they were predicting them with astonishing accuracy, a testament to their advanced mathematical and astronomical knowledge. The most famous evidence of their predictive prowess is found in the Dresden Codex, one of the few surviving Mayan books. This remarkable document contains highly accurate tables of astronomical data, including what is known as an eclipse warning table. This table lists dates for possible solar and lunar eclipses over a period of about 33 years. It demonstrates that Mayan astronomers understood the complex cycles of the moon, including the conditions required for an eclipse to occur, such as the moon being near one of its nodes. They had developed a system to forecast these dangerous periods, allowing their priests and rulers to prepare for the necessary ceremonies to appease the gods. The accuracy of Mayan astronomy was achieved without the use of complex optical instruments. It was the result of centuries of patient, naked-eye observation, coupled with a sophisticated base 20 mathematical system that included the concept of zero. Their ability to track the intricate dance of the sun and moon and predict when their paths would cross was a monumental intellectual feat. For the Maya, astronomy was not separate from religion or statecraft. It was the very foundation of their worldview, a sacred science that allowed them to live in harmony with the cycles of the cosmos and anticipate the dramatic moments when the sky itself would change. In Northern Europe, Vikings had a dramatic mythology to explain eclipses. According to Norse tradition, celestial wolves, Skull and Hedi, pursued the sun and moon. An eclipse meant the wolves caught their prey, a harbinger of Ragnarok. Similar myths existed throughout Europe and Asia. Throughout medieval Europe, eclipses were viewed as omens of the wrath of God, death, or plague. The ancient myths slowly faded with science, but the awe inspired by eclipses remained. For centuries, eclipses transitioned from objects of myth to subjects of scientific curiosity. They were used to measure the size of the Earth and the distance to the moon. But in the early 20th century, a total solar eclipse was poised to play its most significant role yet, to test a revolutionary new theory that would fundamentally rewrite our understanding of gravity, space, and time. In 1915, Albert Einstein published his theory of general relativity, which proposed that massive objects actually warp or curve the very fabric of space-time around them. One of the theory's most stunning predictions was that this curvature should affect the path of light. According to Einstein, light from a distant star passing close to the sun should be bent by the sun's immense gravity. The star would appear to be in a slightly different position than it actually was. The problem was that observing stars near the sun is normally impossible due to the sun's overwhelming glare. The only time such an observation could be made was during a total solar eclipse, when the moon blocks out the sun's light, revealing the stars in the background. The perfect opportunity came on May 29, 1919. A total solar eclipse with over 6 minutes duration would pass over regions with clear skies. The sun would be positioned in front of the Hyades star cluster, providing a perfect field of background sources to measure. British astronomer Sir Arthur Eddington organized 2 expeditions, one to Principe off West Africa, another to Sobral in northern Brazil. Despite challenging weather, the teams captured photographic plates of the stars around the eclipsed sun. When they returned to England and measured the star positions on the plates, comparing them to photographs taken months earlier when the sun was not present, they found a definitive shift. The light bending matched Einstein's predictions and could not be explained by Newton's theory. The announcement made Einstein an overnight international celebrity and ushered in a new era of modern physics, all thanks to a fleeting shadow cast by the moon. Beyond their role in shaping myths and revolutionizing science, eclipses serve another vital purpose. They are celestial clocks of extraordinary precision, allowing modern historians and astronomers to accurately date events in the ancient world. Because the mechanics of eclipses are so well understood, we can calculate the exact date, time, and geographical path of every major solar and lunar eclipse that has occurred for thousands of years into the past. When an ancient text or historical record makes a clear and unambiguous reference to a total solar eclipse, it provides a fixed, absolute anchor point in time, a celestial timestamp that can help calibrate entire historical chronologies. This technique, known as archaeoastronomy, has been used to resolve numerous historical puzzles. For example, ancient Assyrian records mention a solar eclipse that occurred during a war between the Medes and the Lydians, an event so profound that it caused the armies to lay down their arms and declare peace. By calculating past eclipse paths, astronomers have identified this as the eclipse of May 28, 585 BCE, an event now famously known as the Eclipse of Thales. This single celestial event provides one of the cardinal dates of ancient history, a firm peg upon which other events in that period can be reliably placed. Similarly, eclipse records have been invaluable in dating events from other cultures. A line in Homer's Odyssey describes the sky turning dark on the day Odysseus returns home to slay his wife's suitors. Scientists have argued this could be a poetic description of the total solar eclipse that occurred over the Ionian Islands on April 16, 1178 BCE, providing a potential date for the legendary Trojan War. In China, the meticulous eclipse records kept by court astronomers have allowed historians to verify and refine the chronologies of ancient dynasties with a level of certainty that would otherwise be impossible. These ancient observations are a gift from the past to the present. The same events that terrified our ancestors and inspired them to create myths and rituals now provide us with crucial data. Each mention of a darkened sun or a blood-red moon in a historical chronicle, a clay tablet, or even a piece of poetry becomes a potential clue for unlocking the timeline of human history. The shadow of the eclipse, once a symbol of chaos and fear, has become a tool of immense precision, connecting our modern understanding of the cosmos with the lived experiences of those who walked the earth long before us, linking our histories together under the same ever-moving sky. The eclipse begins quietly at first contact, when the moon starts to cover the sun. Through eclipse glasses, a small dark notch appears, slowly growing as the moon moves across the sun. Look for crescent-shaped sunlight under trees, nature's pinhole cameras, while always using proper eye protection. As the sun becomes a thin crescent, daylight turns silvery and strange, shadows sharpen and colors fade. The air cools, birds quiet, and the world feels suspended in anticipation. The sky darkens, excitement builds, and you sense something extraordinary is about to happen. Just before totality, shimmering shadow bands may ripple across the ground, and the sun's last rays break into Bailey's beads. The diamond ring effect flashes, a brilliant jewel in the sky, then vanishes as the moon fully covers the sun. Silence falls, totality has begun. With the sun's glare gone, the corona appears, an ethereal halo of light visible only during totality. Stars and planets emerge in the twilight, and for a few minutes you witness the sun's hidden beauty. The moment is fleeting, unforgettable, and deeply moving. A flash of light signals the end of totality, the diamond ring returns, and the sun reemerges. The world brightens, shadows sharpen, and life resumes. But the memory of the eclipse lingers. As the moon moves away, you're left changed, with a new sense of wonder for the sky. Long after the moon has moved on, the experience of a total solar eclipse continues to resonate. There is a powerful afterglow, an emotional and intellectual imprint that lingers. The memory of the corona blazing in the twilight sky, the 360-degree sunset, and the shared moment of collective wonder is not one that fades easily. It fundamentally changes one's relationship with the cosmos. The sun is no longer just a familiar light in the sky. It is a star of immense power and hidden beauty. Eclipses are a gateway to scientific literacy, transforming abstract astronomical concepts into a shared, visceral, and unforgettable memory. Witnessing the clockwork of the solar system provides a powerful perspective on our place in the universe. Ultimately, experiencing a total solar eclipse leaves an indelible mark. It is a reminder that there are still moments of pure, unadulterated magic in the natural world. While a total solar eclipse is dramatic, its counterpart, the lunar eclipse, presents a different kind of beauty. It is a far more serene, gentle, and leisurely celestial event. Unlike a solar eclipse, whose narrow path demands precise location, a lunar eclipse is a far more democratic event. Earth's shadow is vast, meaning that whenever a lunar eclipse occurs, it is visible to an entire hemisphere. Anyone on the night side of Earth can simply step outside and watch. Watching this process, you can see the clear, curved edge of Earth's shadow creeping across the lunar landscape, visual proof that our own world is a sphere. It is our planet's shadow that is the star of the show. This connects us to the event in a more intimate way. We become participants, not just spectators. The lunar eclipse begins subtly as the moon enters the Earth's faint penumbra. The real spectacle begins when the moon makes first contact with the umbra. A dark scallop appears, slowly creeping across the lunar surface. The contrast between shadowed and unshadowed portions is captivating. The moon is now fully engulfed, marking the beginning of totality. It remains faintly visible, often glowing with a reddish light. This is the moment the famous blood moon is born. The most striking feature of a total lunar eclipse is the astonishing transformation of the moon's color. Instead of disappearing, the moon often takes on a deep, ruddy glow, ranging from copper to a brilliant, fiery red, known as the blood moon. This is a beautiful display of atmospheric physics, a direct result of sunlight interacting with our planet's atmosphere. It is, in essence, the light of all of Earth's sunrises and sunsets being projected onto the lunar surface. This ring is Earth's atmosphere, glowing with reddish light as sunlight streams through it. The reason this light is red is the same reason our sunsets here on Earth are red, Rayleigh scattering. The moon, bathed in filtered reddish sunlight, gives it its spectacular and eerie hue. This effect serves as a powerful reminder of the atmosphere that sustains us. Not all total lunar eclipses are created equal. The color and brightness of the moon during totality can vary dramatically, making each eclipse unique. The specific shade of red depends on Earth's atmosphere. A cleaner atmosphere results in a brighter, more coppery eclipse. Conversely, a dusty atmosphere results in a darker, deeper red, or even brownish eclipse. Major volcanic eruptions can have a dramatic effect, creating a darker shadow. This variability adds suspense to observing each lunar eclipse. Watching the moon turn from white to crimson is to witness a direct link between Earth and the cosmos. It is an event that requires no special equipment beyond your own eyes. It is a peaceful reminder of the clockwork of our solar system. Eclipses have transformed into invaluable opportunities for scientific research, creating a natural laboratory in the sky. The moon acts as a perfect shield, blocking the sun's glare, allowing scientists to study its faint regions. Understanding the sun's behavior is vital, as solar flares can disrupt satellites and power grids. Eclipses provide a rare view of the corona, helping improve space weather models. Scientists use instruments to analyze the light, revealing the corona's composition and temperature. Each eclipse offers new data, and teams travel to remote locations to gather it. This complements observations from spacecraft, building a complete understanding of our star. The greatest gift of a total solar eclipse is the unparalleled view of the solar corona. This vast halo of superheated plasma stretches millions of miles into space. Normally invisible, spacecraft use coronagraphs, but these obscure the most interesting part of the corona. During an eclipse, the moon fits perfectly, allowing us to see the corona in its entirety. This priceless view allows scientists to see the intricate plasma structures shaped by the sun's magnetic field. Eclipse science aims to map the corona's magnetic field by studying the polarization of light. Mapping the field provides vital data for predicting space weather events. Probes like Parker Solar Probe take direct measurements, and combining this data with eclipse observations creates a more complete picture of our star. Modern eclipses provide opportunities for scientific investigations beyond studying the sun's corona. The darkness offers a chance to search for objects normally hidden by the sun. Eclipses also offer a rare chance to study our atmosphere. The moon's shadow creates a cooling effect, generating atmospheric waves. The predictable dimming of sunlight during an eclipse plays a practical role in the calibration of Earth-observing satellites. An eclipse provides a well-understood gradual change in sunlight. Even Einstein's experiment continues to be refined during modern eclipses. Scientists can measure the gravitational bending of starlight with precision. Thus, the eclipse continues to push the boundaries of what we know about space and time. The allure of an eclipse is a powerful force for scientific progress, acting as a catalyst for both technological innovation and human collaboration. The extreme conditions of an eclipse, the brief duration, the faintness of the light, and often the remote viewing locations, push scientists and engineers to develop new, more sensitive and more portable instruments. Each major eclipse sees the deployment of novel cameras with higher frame rates, more advanced spectrographs, and new types of polarimeters, all designed to capture as much high-quality data as possible in the precious few minutes of totality. These technological advancements often find applications in other areas of astronomy and optics long after the eclipse is over. Moreover, eclipses are a powerful driver of public engagement and citizen science. The excitement surrounding a total solar eclipse provides a perfect opportunity to involve the public directly in the process of scientific discovery. Projects like the Citizen Kate or Continental America Telescopic Eclipse Experiment equip teams of volunteers along the path of totality with identical telescopes and cameras. By stitching together the images from all of these sites, scientists can create a continuous, high-resolution movie of the corona's evolution that lasts much longer than the few minutes of totality available at any single location, providing a dataset that would be impossible for professional astronomers to gather alone. These collaborative projects foster a unique and powerful bond between the scientific community and the general public. They demystify the process of research, turning passive spectators into active participants. Volunteers learn how to operate scientific equipment, collect data, and contribute to a genuine scientific investigation. This hands-on experience is incredibly inspiring, especially for students, and can ignite a lifelong passion for science, technology, engineering, and math. The eclipse becomes more than just a spectacle. It becomes a shared national or even international scientific endeavor, a moment of collective learning and discovery for everyone involved. Ultimately, the science of eclipses is a profoundly human story. It is a story of curiosity, of our relentless drive to understand the universe around us. It brings together researchers from different nations, cultures, and disciplines, all united by a common goal. From the ancient Babylonians making their first predictions to the global teams of today launching high-altitude balloons and coordinating satellite observations, eclipses have always pushed us to be better observers, better thinkers, and better collaborators. The fleeting shadow of the moon continues to illuminate not only the secrets of the sun, but also the incredible potential of human ingenuity and our shared quest for knowledge. A total solar eclipse fosters a sense of global unity. The moon's shadow sweeps across the earth, disregarding borders. People from all walks of life gather together, united by a single, upward gaze. The collective gasp of awe greets totality. We all share the same small, fragile planet. Eclipses inspire people to learn more about science and astronomy. It encourages a global conversation about our place in the universe. Our terrestrial concerns can seem small and insignificant. The eclipse unites us in a collective experience of awe. Celestial mechanics ensure eclipses will occur. The next total solar eclipses are already on the calendar, extending a celestial invitation to humanity. These events offer opportunities for discovery, travel, and global unity. The future holds spectacular answers for those chasing the shadow. In 2026, a major eclipse will sweep across the northern hemisphere, beginning over Greenland and crossing to northern Spain. 2027 promises an even more spectacular eclipse with an exceptionally long duration of totality across North Africa and the Middle East. In 2028, the shadow will touch down in the southern hemisphere, sweeping across Australia. Each event is a chance for humanity to gather and share in the unifying spectacle of a total solar eclipse. Witnessing a total solar eclipse is unforgettable, but preparation is key. Identify the path of totality. Modern maps pinpoint the center line, ensuring optimal viewing. Plan accommodations and travel well in advance. Have a backup plan for weather. Never look directly at the sun without certified solar eclipse glasses. On eclipse day, set up early, put cameras down, and be present. No photo replicates seeing the corona with your own eyes. Immerse yourself in this magnificent, fleeting gift. An eclipse reminds us of the universe's order. The sun, moon, and earth align, transforming our sky. It's a testament to the elegant physical laws governing the heavens. This cosmic harmony resonates through human history and our understanding. For our ancestors, this alignment was a source of terror and myth. For scientists, it's an opportunity for discovery, unlocking secrets of our star. We are connected to those who have looked up in awe at the same spectacle. Ancient awe combines with modern understanding, creating a powerful experience. It reminds us we inhabit a single planet, subject to cosmic laws. The eclipse demonstrates that we share one sky. It's a lesson in perspective, part of one grand, interconnected cosmic system. Eclipses have consistently served as a bridge between imagination and reality, pushing the boundaries of our understanding. Early explanations involved myths of celestial dragons or angry gods, our first attempts to make sense of a terrifying event. As curiosity grew, observation inspired the discovery of predictable cycles. The 1919 eclipse confirmed Einstein's theory of relativity, demonstrating the universe's mathematical principles. Today, eclipses inspire art and science, helping us understand space weather and test fundamental theories. They remain a synthesis of science and soul. In many ways, the story of the eclipse is a mirror, reflecting humanity's own journey. How we see an eclipse reveals a great deal about who we are. When we were a young species, living in fear of the unknown, we saw the eclipse as a monster. We started to see not a monster, but a pattern, order, predictability. In the modern scientific era, the eclipse reflects our unyielding curiosity and our technological prowess. When totality arrives, we are united in the same profound awe. In that moment, the eclipse mirrors our shared humanity. Beyond the science, the eclipse offers an enduring invitation to wonder. In our busy lives, we easily disconnect from the cosmos. We rarely look up, but an eclipse shatters this, commanding our attention. It's a celestial intervention, a wake-up call for the soul, extended to everyone. The corona's beauty speaks directly to the heart, awakening curiosity and prompting fundamental questions. Witnessing an eclipse ignites passion for astronomy, reminding us that learning is a human response to the world's beauty. The wonder leaves an indelible mark, shifting perspective. The sun becomes a dynamic star, the moon a celestial partner. This enriches our lives, encouraging curiosity and awe. It's a recurring opportunity to renew our sense of wonder. An eclipse proves there's still magic, the powerful magic of reality. It invites us to cherish our connection to the universe. As we stand in the fleeting shadow of the moon, watching the sun veiled in glory, or the moon bathed in the soft red light of Earth's own shadow, we are inevitably led to reflect on our own ephemeral place in the vastness of the cosmos. These events are powerful moments of perspective. They reveal the immense scale of the solar system and the delicate celestial mechanics that make our existence possible. We are reminded that we live on a planetary body, a sphere of rock and water that is constantly in motion, participating in a grand and ancient cosmic ballet. It is a humbling and deeply moving realization. Eclipses are more than mere astronomical alignments. They are moments of intense and powerful connection. They connect us to the physical universe, allowing us to see and feel the clockwork of the heavens in a direct and visceral way. They connect us to our own history, to the countless generations of humans who have looked upon the same sight with fear, reverence, and curiosity. And most importantly, they connect us to each other. They unite people across the globe in a shared experience of awe, dissolving borders and reminding us of our common identity as inhabitants of a single precious world. The story of the eclipse is the story of our journey toward the light, both literally and figuratively. It is a narrative that has taken us from the darkness of fear and superstition into the light of scientific understanding and shared appreciation. The shadow that once terrified us has become a source of profound knowledge and unifying beauty. It has driven pivotal scientific revolutions, inspired timeless art, and shaped the course of human cultures. The brief darkness of an eclipse ultimately serves to illuminate our world, our star, and ourselves in a new and more brilliant light, revealing a universe of exquisite order and harmony. And so we are left with a final, lingering feeling of gratitude. We are fortunate to live on a planet with a moon of just the right size and at just the right distance to create such a perfect spectacle. We are privileged to be the inheritors of centuries of knowledge that allow us to understand and predict this celestial dance. Eclipses are fleeting, intensely powerful moments of cosmic harmony, revealing an underlying order and inviting us to forever look up, to wonder, and to marvel at the boundless, beautiful, and intricate universe that we are so lucky to call home.